Okay, let's take a look at scientific notation. Scientific notation gives us an easy way to represent very big and very small numbers. And in radiology, we'll find that we often have to deal with very large or very small numbers. Here's an example. We have 8,300,000. Now, we'll actually deal with much bigger numbers, but we can see that even when a number gets this big, we have to write down a lot of digits, a lot of zeros to represent the number. And what we want to find is a better way to do it, or a shorthand way to write down a very big or a very small number. Let me show you how this works. When we have a number like 8,300,000, another way to think about that is it's equal to 8.3 times 1 million. Now, if you look at that, you say, well, that's not simpler, that's harder. But here's where the trick of scientific notation comes in. We could represent 1 million as 10 to the 6th power. And so we finish this off by writing it as 8.3 times 10 to the 6th. And that's scientific notation. Let me show you a trick for how to quickly get to scientific notation when you have a very big number. Basically, the power of 10 can be found very quickly by just counting how many places are you moving the decimal. So in other words, the decimal is starting here, and we want to write this as 8.3. So what we do is we simply count over how many places we move the decimal. So 1, 2, 3, 4, 5, 6. And you'll notice that quickly tells us that it's 10 to the 6th power, because each time we move the decimal, that's just another power of 10. Let's see how we can use scientific notation to represent very small numbers. Okay, so in my example, I have 0.000000976. So the first thing I'm going to do is I'm going to rewrite that as 9.76 divided by 10 million. Now, it might not be immediately obvious to you that that's equivalent, but if you go ahead and try it on your calculator, take 9.76 and divide by 10 million, you'll see that yes, you get back to our original number. Well, the next thing I'm going to do is I'm going to write 10 million using exponents. So that's simply going to be 10 to the 7th. Because again, I've got 1, 2, 3, 4, 5, 6, 7 zeros, and that's the equivalent of 10 to the 7th. Then I'm going to remember a rule that we talked about when we covered exponents, that a to the minus b is the same as 1 over a to the b. So I can write this as 9.76 times 10 to the negative 7. And that's how we would represent that number. Now, let me show you the trick to doing it much more quickly than having to figure it out that way. And the trick is that every time I move the decimal to the right, that is a negative power of 10. So if I go 1, 2, 3, 4, 5, 6, 7, then that would be 9.76 times 10 to the negative 7. And so you'll notice that if I move the decimal to the left, I increase the exponent, and if I move it to the right, I decrease the exponent. The next thing we want to look at is how do I do mathematical operations when I have numbers in scientific notation. The first one we want to look at is how to multiply numbers in scientific notation. And so we've got to do three things. We have to multiply the numbers before the powers of 10. We add the exponents of the powers of 10. And then we have to put it in standard form if it doesn't end up in standard form. And the standard form for scientific notation is simply you should only have one digit to the left of the decimal. So let me show you how this works. Okay, so here's my example. And what the what the rule says to do is multiply the numbers before the power of 10. So in other words, I take 8.3 and I'm going to multiply that by 4.1. So that's the first thing I'm going to do. And then it says simply add the exponents of the powers of 10, because we know that that's valid for exponents. So that would be times 10, and then I have the 3 and the 7, and I want to add them. So the next step, I'd actually do 8.3 times 4.1 on my calculator, and I get 34.03. And then 3 plus 7 is 10, so I would have 10 to the 10th. Now, I'm almost done, but the standard form of scientific notation says you should only have one digit to the left of the decimal place. And so if I'm moving that decimal to the left by 1, so I have 3.403, then remember, anytime I move the decimal point to the left, I need to increase the exponent. And so I would have 10 to the 11th. Okay? And if I had had to move the decimal 2 places, then I would have had 10 to the 12th. Okay? The other way to just remember that is that I went from 34 to 3.4, so I made that front number smaller. Therefore, I have to make the exponent larger, so go from 10 to the 10th up to 10 to the 11th. And so that's the answer. Let's take a look at the rule for dividing. For dividing numbers, again, it's very similar. I divide the numbers before the powers of 10, I subtract the exponents, and then again, I put it in standard form if I don't happen to end up there. So let's take a look at an example. So the first thing it says to do is divide the numbers before the power of 10. In this case, I have 4.3 times 10 to the 3rd, and I'm dividing it by 8 times 10 to the 7th. So I have 4.3 divided by 8, and then I want to subtract the exponents, just like we know to do whenever we're dividing exponents. So I have 10 to the 3rd, and I'm dividing by 10 to the 7th, so that would be 3 minus 7. I would now take my calculator and do 4.3 divided by 8, and I would get 0.5375, and the power of 10 would be to the minus 4. Okay, we're almost done. Now in this case, I don't have any digits to the left of the decimal place, and I want to always have 1. So since I have to move that decimal point 1 to the right, anytime I move the decimal to the right, I have to make the exponent smaller. So here I'm moving it to the right by 1 step, or by 1 digit, and so that means I have to make the exponent 1 smaller. Okay? And that would be the answer. Now, we can actually do calculations with scientific notation using a calculator. And again, I'm just going to demonstrate this for the Windows calculator and also for the TI-83. If you have a different calculator, I can show you how to do it on your calculator in class. One of the things to keep in mind is when a calculator shows you a number in scientific notation. For example, let's say the calculator wants to show you 3 times 10 to the 4th. The way most calculators do that is they display it this way, 3E4, okay? Or they might use a capital letter, 3 capital E 4, okay? So keep that in mind, that that's the way a calculator displays 3 times 10 to the 4th. So that's just a shorthand way that the calculator is able to display it. All right, so how would I put a number into the calculator using scientific notation? The way I would do it is, if I want to put in 3 times 10 to the 4th, I first hit the 3, and then on the Windows calculator, I would hit the EXP key, and then I would put in the 4. And that's how I would enter that number in scientific notation. I could then hit whatever mathematical operation I wanted to do. Let's say I wanted to do times, and then I could put in another number in scientific notation in just the same way. On a TI-83 or a TI-84, again, I would first hit the number 3, which in this case I don't have on my slide, but I would do that. And then I would hit the second function, and then this key. And it's hard to see in my graphic, but that little symbol there says EE, and that represents how to put a number in scientific notation. So I would press that, and then I would hit the number I want for the power. And this is how the calculator would display it, 3e to the 4. So we'll do this together in class with each of your calculators just to show you how to do it. Okay, the last rule that we want to look at is what do I do if I want to add or subtract a number that's in scientific notation? So the first thing I would do is convert the number with the smaller exponent to one with the larger exponent, and then I add the front numbers. Now, I want to show you why it is we have to do that. So here's my example. I have 7.6 times 10 to the third plus 3 times 10 to the 2. Now, I'm going to first do it without scientific notation just to kind of show you, justify why we have to do it the way we do. If you think about what 7.6 times 10 to the 3 is, that is 7,600. And if you think about what 3 times 10 to the 2 is, that's just 300. So if we didn't use scientific notation, we could see the answer is 7,900. So now let's make sure that we get the same thing when we do it in scientific notation. So you'll notice that the 7 here really means 7,000, and the 3 here really means 300. So I can't just add 7 and 3. And that's why before we can add, we have to convert the numbers so they're at the same power of 10. And what I tell you to do is convert the number with a smaller exponent to the one with a larger. And what I mean by that in this case then is write this as something, the second number, as something times 10 to the third. Now think about what we're doing here. We've just made this number bigger by a power of 10. So we have to make this number smaller by a power of 10. And so that becomes 0.3 times 10 to the third. Once I've got the numbers to the multiplied by the same power of 10, I can now just add as I normally would. So 7.6 plus 0.3 would be 7.9, and then the exponent just stays the same when I'm adding, okay? And that's also true when I'm subtracting. And so that would be our answer in scientific notation, and you'll notice that that is the same as 7,900, which is what we had ended up with without doing it in scientific notation. Let's take a look at one more example. In this case, I'm going to do a subtraction. So I have 4.658 times 10 to the 7th minus 2.9 times 10 to the 5th. So remember, the first thing I've got to do is take the number that's smaller, or to the smaller power of 10, and convert it to the same power of 10. So I have 4.658 times 10 to the 7th minus something times 10 to the 7th. Now again, I made this 2 powers of 10 bigger. That means I have to move the decimal place over 2. So I get 0.029 times 10 to the 7th. Once I've got that, now I just take 4.658, subtract 0.029, and that's just times 10 to the 7th. And if you do that on your calculator, you get 4.629 times 10 to the 7th, and that's the answer.